Now, as I was telling you, I have to separate H. So that you have to do very tactfully. See what I will do in this case. Now, Gm by R plus H should be equal to twice Gm, okay, twice Gm minus V square by R, V square into R divided by twice R. Or we can write R plus H by Gm should be equal to twice R by twice Gm minus V square into R. Or we can write R plus H equal to twice R G into capital M divided by twice Gm minus V square R. Or H is equal to twice R Gm by twice Gm minus V square into R minus R. Look, up to this mark don't put any value. Now you substitute the values. All the values are given. You can check the question. All the values are given. Radius of the earth, capital G, mass of the earth. And velocity already we have got. The value of the velocity is here minus 5 kilometer per second, 5 into 10 cube meter per second, minus. You have to, now I think remaining portion you can very easily do. This is not at all difficult. Now you just solve it and you can tell me the answer. In case of any problem you can ask me, but main thing how to solve it, that I have given you the clue. Now the mathematics. Main clue I have given you. Fine. Now, I hope, dear students, similarly you can solve a lot of questions are of this type in the book. You can see. So I hope those questions you can solve. Another question. Again, the type is changed. Again, I am coming to question number 8.18. It's also a very important question. Look, a very important question it is. It is here. The escape speed of a projectile. It is on the escape speed. The escape speed of a projectile on the Earth's surface is 11.2 kilometer per second. जो होता है. A body is projected with thrice this speed. What is the speed far away from the Earth? Ignore the presence of the Sun and other planets. Okay, fine. Again, here is this is O, this is R. Again the point here, it is thrown, V is equal to thrice, I write here, V is equal to thrice VE. इसको जो थ्रो किया गया, that is thrice the escape speed, mind this. So here it is. I am throwing it with thrice the escape speed. तो बोल रहा है कि look at the language of the question. What is the speed of the body far away from the earth? Far away from the earth means, suppose the point B I am considering where the V is equal to V. Okay, far away from the earth, undefined thing. If I say far away from the earth, that means you will say, okay, it is the undefined thing. It cannot be defined. What is the meaning of far away from the earth? What distance we should take? Infinity. Again, I will use conservation principle of energy. Obviously, by conservation principle of energy, kinetic energy plus gravitational potential energy at A is equal to kinetic energy plus gravitational potential energy at B. Simple. Kinetic energy and gravitational potential energy. So here definitely gravitational potential energy. So what is kinetic energy? At a half m v square. Obviously, in this projectile, the mass of the projectile is small. Mass of the earth is capital plus gravitational potential energy. Here the gravitational potential energy will be minus g capital M into small m by r, just like the previous case. And here is the kinetic energy at b पर इसका velocity मान लिया जाए v है. So half m v square plus here minus g capital M into small m by, I write infinity because I am considering the distance to be infinite. When it is going here, its distance is infinite. Here capital M and small m, mass of the earth and the projectile respectively. Mass of the earth and mass of the projectile respectively. Okay, then what we shall get? Let it be like this. See, half m just a minute. Half m, better we write it v dash. It is here v dash. Otherwise you may confuse. Here it is thrice v, so 3v whole square minus g capital M into small m by r is equal to half m v dash square. V dash is the velocity at the point B which we have to determine. If you remember my derivation, when I have derived escape velocity, you can see the derivation of the escape velocity. In that derivation of the escape velocity, you can get half m 9v square minus, you will get, this is half mv square. Once you can see the notes, you will see the notes. In the notes, g capital M into small m by r का value half mv square. उसको निकाल करके तुम देख लो. That should be equal to half mv dash square. Half m, or cancel. So v dash square is equal to, it is 8v square, which implies v dash is equal to twice root 2v, और v का वैल्यू दिया हुआ है 2 root 2 into 11.2 kilometer per second. Tally the answer. You can just tally the answer. It's very simple. I hope you can do it easily. It's an important question. Mind this. It's an important question. It's a very important question from the examination point of view as well as from the competitive examinations point of view also. Okay? This is. And now, here. I am discussing now, again, as I told you, different type of questions. Let us now discuss the question number 8.21. Different type of question. Two heavy spheres, each of mass 100 kg and radius 0.1 meter, are placed at 1 meter apart on a horizontal table. What is the gravitational force and the potential at the midpoint of the line joining the centers of the squares? Okay. Here. Look, 1 meter is the whole distance. Here is the point O. This is the point center A, this is the center B. And this is also 100 kg, this is also 100 kg. Look, it's like this, 100 kg and 100 kg are placed. It is said that first you find out the gravitational force. What is the gravitational force on this at the point is? Okay, what will happen? Here, suppose I consider gravitational force कितने के बराबर होता है. अगर मैं कंसीडर करूं यहां पर एक मास m रखा हुआ है ना, तो क्या होगा? ग्रेविटेशनल फोर्स इस पॉइंट, इस मास पर ग्रेविटेशनल फोर्स यहां पर कितना होगा? तो सबसे पहले मैं कंसीडर करूंगा, मेरी बात को ध्यान से सुनो, मैं कंसीडर करूंगा यहां पर ग्रेविटेशनल फील्ड कितना होगा. फील्ड किसके लिए होता है? यूनिट मास के लिए होता है. यूनिट मास अगर है तो ये बॉडी लार्जर बॉडी है, ये इधर खींचेगा, ये लार्जर बॉडी है, इधर खींचेगा. ठीक है? हियर इट इज E1, हियर इट इज E2. ऑब्वियसली E1 शुड बी इक्वल टू, ऐसे लिखते हैं, ग्रेविटेशनल फील्ड ठीक है. हियर gravitational field at O, that is E1 is equal to E2 is equal to G into 100 divided by 0.5 whole square. I hope you remember. Right. Since as these fields are equal and opposite, net field E at O is equal to 0. So E is equal to 0. Force at O is equal to mass. यूनिट मास जितना फोर्स एक्सपीरियंस करता है वो फील्ड है, तो कोई फाइनाइट मास m जितना एक्सपीरियंस करेगा वो फोर्स हो जाएगा. कितना हो जाएगा? 0. सो नेट फोर्स इज 0. नेट फोर्स इज 0. एंड नाउ व्हाट अबाउट द ग्रेविटेशनल पोटेंशियल? ग्रेविटेशनल पोटेंशियल एट O due to each A and B. V1 equal to V2 equal to कितना होगा? माइनस जी m बाई आर. ये फॉर्मूला होता है. माइनस जी इंटू 100 बाई आर इज 0.5. इतना. ठीक है. सो as gravitational potential is a scalar quantity, it is a scalar quantity, net gravitational potential at O, V is equal to V1 plus V2 minus G into 100 by 0.5 plus minus G into 100 by 0.5. That is equal to minus 2G into 100 by 0.5. इतना जूल पर kg. इसको आप ऐसे निकाल लो. You can find out the answer. So gravitational field and force will be 0 at O, but potential will not be 0. पोटेंशियल ऐसे निकलता है. ये स्केलर क्वांटिटी है, सिर्फ डायरेक्शन में ही देखा जाता है, स्ट्रेट में जोड़ दिया जाता है. ऑलराइट.